Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer, and the seminars are at smarturl.it/btdt-online. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today. For exam LTAM, you are using the following model to price a 10-year disability income insurance policy issued to X years old. So as you can see, states are healthy, sick, and dead, and you can go back from being sick to being healthy. You can go from healthy to being sick. You can go from healthy to being dead, and from sick to being dead. The product has the following features. Policyholders are healthy at the issue date. A benefit of $20,000 is payable immediately on death within 10 years. A continuous benefit of $1,000 per year is paid while the policyholder is in the sick state during the 10-year term. Premiums are payable continuously while the life is in the healthy state. Maintenance expenses are paid at a continuous rate of $60 per year while the insured is alive. Commissions are payable continuously at the rate of 5% of gross premium. No benefits, premiums, or expenses are payable beyond 10 years. You're also given the force of transition from state 0 to state 1 at age x plus t is 0.03. Transition from 0 to 2 at age x plus t, the force is 0.02. Transition from state 1 to state 0 at age x plus t is 0.01. Transition from state 1 to state 2 at age x plus t is 0.05. For T positive, the force of interest is 7%. Annuity payable, temporary 10-year life annuity payable for a person starting in state 0, payable while the person is in state 0 is 5. Actuarial present value of it is 5.844. The same annuity payable while the person is in state 1. Actuarial present value is equal to 0.684. Life insurance payable upon transition from state 0 to state 1. Actuarial present value is 0.175. It's temporary 10-year annuity, and then transition from the same, but for transition from state 0 to state 2 is 0.151. And here are the questions. Part A. Show that the gross premium rate calculated using the equivalence principle is 738 to the nearest 1. You should calculate the value to the nearest 0.1. Part B. Calculate the probability that the life dies without becoming sick within the 10-year term. The insurer offers a new product with the following features. For any period of sickness that starts within the 10-year term, the benefit of $1,000 per year is paid until death or recovery, even if that occurs after the 10-year term. There is an elimination period of 1 year. After other policy features and assumptions, all other policy features and assumptions are the same as given above. Part C. Define the term elimination period in the context of a disability income insurance product. Part D. Show that the expected present value of a 1-year continuous sojourn annuity in state 1 is A bar x colon angle and 1 with a bar above it is 0.94 to the nearest 0.01. You should calculate the value to the nearest 0.0001. And Part E, calculate the premium for this new policy using the model and parameters given above. Just a reminder, a sojourn annuity is an annuity for someone in state I that pays only while no transition from state I is made. So continuously remain in that state. And that's what that bar symbol always refers to, the bar above the the states that you see there. So if you'd had 0, 0 bar, that means start in state 0, always in state 0. And here's the solution. Let us write G for the gross premium rate sought. We use the equivalence principle to write that G A bar X colon angle 10, 0, 0 is equal to 20,000. A bar X colon angle 10, 0, 2. So the left-hand side is just the actuarial present value of premiums, gross premiums, and the first term here is the actuarial present value of a death benefit plus 1,000 A bar X colon angle 10, 0, 1. It's the actuarial present value of sickness benefit plus 60 times A bar X colon angle 10, 0, 0 plus A bar X colon angle 10, 0, 1. That's the actuarial present value of maintenance expenses. Just remember they're paid as long as the person's alive, so also while in disability. And then or sickness, while in sickness. And then 0.05 G times A bar X colon angle 10, 0, 0, that's the actuarial present value of commissions. We solve for G, and we get G is equal to 20,000 A bar X colon angle 10, 0, 2 plus 1,000 A bar X colon angle 10, 0, 1 plus 60 times the sum of A bar X colon angle 10, 0, 0 and 0, 1. And the whole thing is divided by 0.95 A bar X colon angle 10, 0, 0. All of these numbers are given. We plug them in. We get approximately 737.721,099. Part B, the probability that the life dies without becoming sick within the 10-year term is the integral from 0 to 10 of TPX 0, 0 with a bar times mu x plus T02 dt. So continuously in state 0 and then drop dead from transition from state 0 to state 2. And that's equal to the integral from 0 to 10 of e to the minus 0.03 plus 0.02 t. And I didn't have the minus, I just corrected it, I apologize, times 0.02 dt. And that's equal to 0.02, we just factor it out, times the integral from 0 to 10 of e to the minus 0.05 t dt. That's just 0.02 times A bar angle 10 at delta equal to 5%. And that's 0.4 times 1 minus e to the minus 0.5. That's approximately equal to 0.15738774. Part C, the elimination period or waiting period is the time between the beginning of disability, sickness, and start of the payments by the disability income policy. Part D, we have A bar X plus T colon angle 1, 1 with bar above them, so a sojourn annuity, is equal to integral from 0 to 1 of e to the minus 0.07 t times TPX 1 with a bar above it, which is the integral from 0 to 1 of e to the minus 0.07 t times e to the minus mu 10 plus mu 12 t dt. That's equal to integral from 0 to 1 of e to the minus 0.07 t times e to the minus 0.01 plus 0.05 t dt, and that's just the integral from 0 to 1 of e to the minus 0.13 t dt. That's equal to A bar angle 1 at force of interest of 13%, so this is equal to 1 minus e to the minus 0.13 over 0.13, that's approximately 0.93772745. For part E, let us write G star for the gross premium for the new policy. The equation to derive the premium previously was, so here it is, and simply an application of the equivalence principle. Now things are changing, but not all of them, so the death benefit expected present value is unchanged, is 3,020, just as before. The sickness benefit expected present value now includes the additional benefit, and it becomes 1,000 times the integral from 0 to 10 of e to the minus 0.07 t times TP x 0, 0, so stay in state 0 probability, times mu x plus t 0, 1, meaning that you get transition to state 1, times a bar x plus t 1, 1 with a bar above it, minus a bar x plus t colon angle 1 with 1, 1 with a bar above it. The second term is the adjustment for the elimination period. Okay, we calculated the second term just a moment ago, and then the rest becomes 1000 times 0 from 0 to 10 of e to the minus 0.07 t times tp x 0, 0 times mu x plus t 0, 1 times the integral from 0 to plus infinity of e to the minus 0.07 t s times sp x plus t 1, 1 with a bar above it ds minus what we just calculated before. This probability of continuously remaining in state 1 is calculated just by adding the forces of going out and putting them in the exponent, so it's e to the minus 0.06 s ds. So we plug that in, and of course you can see that this integral from 0 to plus infinity becomes the integral from 0 to plus infinity of e to the minus 0.13 ds, so that's of 0.13 as ds, so that's equal to 1 over 0.13, because it's a angle infinity at a force of interest of 13%. So this becomes 1000 integral from 0 to 10 of e to the minus 0.07 t times tpx 0, 0 times mu x plus t 0, 1 times 1 over 0.13 minus 1 minus e to the minus 0.13 over 0.13. Well, of course, 1 over 0.13 minus 1 over 0.13 just cancel out, and what we're left with is e to the minus 0.13 over 0.13. We put it in front as we get 1000 e to the minus 0.13 over 0.13 times the integral from 0 to plus infinity of e to the minus 0.07 t times tpx 0, 0 times mu x plus t 0, 1 dt. That's equal to a bar x colon angle 10, 0, 1. And that's given as 0.175, so we just plug it in, calculate it, and it's approximately 1182.05154. Maintenance expense expected present value now becomes 60 times a bar x colon angle 10, 0, 0 plus integral from 0 to 10 of e to the minus 0.07 t times tpx 0, 0 times mu x plus t 0, 1 times a bar x plus t 1, 1 with a bar above it, because maintenance expenses are payable while the person is alive, either alive and healthy or alive and sick. And the second expression we know it to be 0.175 over 0.13. So we just plug everything in, we get 431 times 0.409231, and G star is equal to 3020 plus 1182.05154 plus 431.409231 divided by 0.95 times 5844. That's approximately 834.587125. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.